Thermal interface materials, or TIMs, are used to ensure a strong thermal connection between the LED array substrate and the heatsink or fixture. The use of TIMs protects from manufacturing deficiencies like substrate warpage and heatsink flatness. There are three common styles of TIM used with LED arrays: thermal pads, phase change materials, and thermal grease. TIMs are manufactured to a variety of thickness specifications. The selection of a TIM that is too thin can lead to inadequate contact between the two surfaces. In contrast, a TIM that is too thick can create warpage in the array substrate during mounting. Bridgelux recommends specific ranges of thickness for TIMs based on the size of the substrate. For information regarding specific Bridgelux arrays, please see the thermal application note on the Bridgelux website. A thermal pad allows for simple manufacturing assembly. Many manufacturers will have available thermal pads that have been die cut to match Bridgelux LED array substrates. Thermal pads are shipped with protective linings on one or both sides to prevent damage. Remove the protective liner from one side of the pad and place onto the array while applying a small amount of pressure to remove air bubbles. Most thermal pads have a tacky texture and will stick to the substrate. Next, remove the protective liner from the other side and apply to the heatsink. Use a light, even pressure and be certain not to press down on the LES. Phase change pads have similar thermal resistances to those of a thermal grease and can be applied like a thermal pad. They blend the ease of assembly of a pad with the thermal conductivity of a grease. As with thermal pads, phase change pads can be die cut and must be of an appropriate thickness for use with LED arrays. Thermal greases are usually graphite-based or polymeric substances. They are most commonly provided in jars, syringes, or tubs to be applied by hand or with the use of a dispensing system. The use of a syringe allows thermal grease to be dispensed in a measured amount in the center of an array or in a pattern across the back of a substrate. Uniform coverage is critical and can be additionally managed during the mounting process. Whether using a syringe, spreading stick, or other tool, the use of a pattern stencil and squeegee can significantly improve uniformity and consistency during the manufacturing process. Place the grease in the stencil and use a squeegee to pull the grease across the stencil to fill the space. Remove the stencil and mount the array to the heatsink. When you mount the array to the heatsink, it is recommended that the array is rotated back and forth slightly to ensure the thermal grease is spread out. Appropriate torque should also be applied. Screws should be tightened in an alternating method, moving from screw to screw so as not to torque down completely on one side before the other. The tightening should be done with quarter or half turns and alternating back and forth between the screws. As with thermal pads and phase change materials, the thickness or quantity of thermal grease must be carefully measured. Too much can cause excess grease to ooze out of the side holes and edges. Too little can leave gaps in thermal transfer, which can cause hot spots on the array. These hot spots can lead to catastrophic failures. Controlling the temperature of LED arrays is critical for luminaires and lamps. A thermal interface material is a vital piece of the thermal management system.